Good morning, my dear students. Welcome back to plus 2 physics class. Okay, in the last video we discussed the properties of electric charge. Okay, properties of electric charge is discussed in the last session. Okay, today we are continuing that session, that is properties of electric charges. Okay, in the last class we discussed three properties of electric charges. One is the electric charge are of two kinds. Okay, that is the electric charges are two types. One is positive charge and second one is negative charge. Okay, and second property, the like charges. Okay, the like charges are repelled and unlike charges what? Attracting. Okay, that is positive and positive or negative and negative are repelled and positive and negative are attracting. Okay, that is second property. And the third, the two kind of charges, positive and negative, are really opposite. Okay, are really opposite. That is the combination of charge plus q and with the minus q. Okay, plus q with the minus q result in net charge is equal to 0. Okay, that is the charges, that is the two kind of charges, positive and negative, are really opposite. That is plus q and minus q. Okay, its net charge, what is its net charge? It's 0. Why? Plus q plus minus q means what? 0. Okay, that is the net charge is 0. Okay, these properties are discussed in the last class. Okay, today we are continuing these properties of electric charges. Okay. Okay, then next property, that is charge is quantized. Okay, charge is quantized. That is, Millikan showed that all electric charges, okay, all electric charges in nature exist either as a basic charger, as some integral multiples or integral multiple of this charge. Okay, that is the basic charge is equal to electronic charge. The basic charge is equal to electronic charge. That is the Millikan showed that all electric charges in nature, okay, all electric charges in nature exist either as basic charges as some integral multiples of this charge. Okay, the basic charge is equal to the electronic charge. Here one electronic charge E equal to, that is the basic charge, okay, basic charge or electronic charge E equal to 1.602 into 10 raised to minus 19 coulomb. Okay, 10 raised to minus 19 coulomb. Okay, this is the basic charge or electronic charge E equal to 1.602 into 10 raised to minus 19. Okay, that is there are in this case there are 6 into 10 raised to 18 electrons exist in minus 1 coulomb charge. Okay, that is there are 6 into 10 raised to 18 electrons exist in 1 coulomb charge body. Okay, that is here thus the charge exist in distinct, okay, thus the charge existing in discrete packet or charge is said to be quantized. Okay, here the charges is like a packet. Okay, in a body the charges are like a packets arrangement. Okay, that is, it is said to be quantized. That is, according to quantization, okay, according to quantization of electric charge, charge of a body is an integral multiple of basic charge. Is an integral multiple of basic charge, which is the electronic charge. Okay, which is the electronic charge. That is the basic charge on a body. Charge on a body Q equal to, okay, charge on a body. We have in a packet there are number of electrons are available, and one electron charge is 1.6 into 10 raised to minus 19 coulomb. Therefore, the charge on a body Q equal to plus or minus Ne. Okay, plus or minus Ne. Okay, here N is the number of electrons, or it is an integer. Okay, it is 1, 2, 3, etc. Clear? And E is what? Electronic charge. That is the value of electronic charge, what? E equal to 1.6 into 6.602 into 10 raised to minus 19 coulomb. Okay, 10 raised to minus 19 coulomb. This is the equation for charge. Charge Q equal to Ne. Okay, for example, if in a body the number of electrons is 2, okay, then what is the charge on a body? Q equal to plus or minus 2 into what is E? E equal to 1.02 into 10 raised to minus 90. Okay, that is, we get the multiplication value from this. Okay, this is the charge is a quantized. That is, the charges are arranged in a body is like a quantized or the packet. Okay, or in a body the charges are seen in a packet of. Okay, that is, it is quantized. Clear? And the fifth one is charge is conserved. Charge is conserved. Okay, in the lower classes you studied the conservation of momentum, conservation of energy, etc., or conservation of mass, etc. Okay, here the charge is conserved. Okay, charge is conserved. What is the meaning of that? It means that the total charge of an isolated system, okay, total charge of an isolated system remains constant. Okay, remains constant. That is, in an isolated system, the total charge of that system is remain constant. Or it also implies that the electric charge can neither be created nor be destroyed. Okay, that is, the electric charges can neither be created nor destroyed. If an object lose some charge, if some object lose charge, an equal amount of charge appear somewhere else. Okay, for example, from this chalk the electrons are loosed. Suppose from this chalk the electrons are loosed, that charge appears somewhere else. Okay, that is, it is neither be created nor be or nor destroyed. Clear? Okay, this is the fifth property, that is charge is conserved. And one more thing, charge is a scalar quantity. Okay, charge is a scalar quantity, not a vector quantity. Okay, charge is a scalar quantity, that is sixth one. Okay, sixth one is charge is scalar quantity. Charge is a scalar quantity. Okay, clear? Okay, then the last property, that is the seventh one, additivity of charge. Okay, additivity of charge. Of charge. Additivity means what? Sum, adding, that is additivity. Okay, the sum of, okay, or algebraic sum of. Clear? Okay. The total charge on a surface is the algebraic sum of individual charges present on that surface. Okay, that is, the total charge on a surface is the algebraic sum of individual charges present on that surface. Okay, if Q1, Q2, Q3, Q4, etc. up to Qn, okay, to Qn are the charges on a surface, then the total or net charge is considered as Q equal to Q1 plus Q2 plus Q3 plus etc. up to plus Qn. Okay, Qn. Clear? That is, the total charge on a surface is the algebraic sum of individual charges present. Okay, individual charges present on that surface. Okay, if Q1, Q2, Q3, Q4, etc. up to Qn are the charges on the surface of a body, that time the total charge or the net charge is equal to Q1 plus Q2 plus Q3 plus etc. up to Qn. Okay, this is the additivity of charge. Okay, these are the properties of charges. Okay, that is, today we discussed some properties. One is charge is quantized. Okay, charge is quantized and charge is conserved. Then charge is a scalar quantity. Then additivity of charge. Okay, total we discussed 7 properties of electric charge. Clear? Okay. Okay. Then next topic, very important topics. That is, first one is point charges. Okay, point charges. Listen, if an electric charge is confined to an extremely small volume, okay, that is, an electric charge is confined to an extremely small volume, it is called a point charge. Okay, it is called point charge. That is, if an electric charge is confined to an extremely small volume, okay, extremely small volume, it is called what? Point charge. Or physically, all charged bodies, all charged bodies whose dimensions are very small. Dimensions means volume, length, area, etc. Okay, that is, its dimensions are very small compared to the distance between them are referred to as point charges. Okay, that is, any charge whose dimensions are very small compared to its distance from a point where its effect are to be analyzed is also called what? Point charge. Okay, point charge. Okay, this is a simple definition. Okay, simply you study the definition of this point charge. Okay, next we are going to discuss very important topic in this chapter, that is Coulomb's law. Okay, Coulomb's law or inverse square law. Okay, inverse square law. Okay, listen. Coulomb's law, or it is also called what? Inverse square law. Okay, inverse square law. Okay, inverse square law. Okay, listen. Here, this inverse square law or Coulomb's law states that the force between, listen, the force between two stationary electric charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Okay, we have in a body, every electrons are attracting each other, that is, two charges are having attractive force. Okay, attracting force. Here, what is that in Coulomb's law? That is, the force of attraction or force between two stationary electric charges is directly proportional to the, okay, is directly proportional to the product of the two charges. Okay, product of the two charges, and inversely proportional to the square of the distance between them. Okay, listen, let us consider two stationary electric charges. Okay, that is, here I am considering two stationary electric charges. One is Q1 and this is Q2. Okay, Q1 and Q2, and separated by a distance R. Okay, separating by a distance R. Then according to Coulomb's law, what is Coulomb's law? States that it is the force of attraction between these two stationary charges is directly proportional. That is, the force is directly proportional to the product of these two stationary charges, that is Q1 into Q2, and inversely proportional to, that is, F is inversely proportional to the square of the distance between them. Okay, that is 1 by R square. Okay, 1 by R square. Okay, this is state our Coulomb's law. Okay, that is, the force of attraction between two stationary charges is directly proportional to the product of these two charges and inversely proportional to the square of distance between them. Clear? Okay, I am combining these two equations, that is, F is proportional to Q1 Q2 by R square. Okay, Q1 Q2 by R square. Clear? Okay, I am changing this value into a equation. Okay, that is, we get F equal to, from this we get F equal to 1 by 4 pi epsilon 0 is then 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay, Q1 Q2 by R square. Okay, here this value, okay, this 1 by 4 pi epsilon 0, okay, 1 by 4 pi epsilon 0 is a constant, that is this proportionality constant. Okay, here this epsilon 0, okay, this epsilon 0 is called permittivity of free space. Okay, permittivity of free space. Okay, permittivity of free space, and its value, the value of this permittivity is epsilon equal to 8.85, is an 8.854 into 10 raised to minus 12. Okay, minus 12 Coulomb square per Newton meter square. Newton meter square. Okay, Newton meter square. Clear? Okay, this is the very important equation in this session. Okay. Okay, here we studied, here the epsilon 0 is the permittivity of free space, or epsilon r, listen, epsilon r is the, this is in free space, okay, free space, but this epsilon r is the permittivity of the medium in which the charges are placed. Okay, if a charge is placed in a free space, that time this permittivity is taken as epsilon 0. Okay, if the charge is placed in another medium, that time it is called what? The relative or permittivity of medium. Okay, permittivity of medium. Clear? Listen, the relativity of permittivity of free space and is called relative permittivity or dielectric constant. Okay, whose value in free space is 1. Listen, epsilon r is the permittivity of the medium in which the charge are placed. The relative to the permittivity of free space and is called relative permittivity. Okay, relative permittivity or dielectric constant. It is also called dielectric constant. In free space it is called relative permittivity and whose value is 1 for free space. Okay, that is the epsilon r is 1 in the case of free space. Okay, in the case of free space the epsilon r is 1. This epsilon r is called what? Relative permittivity or dielectric constant. Okay, dielectric constant. Clear? Okay, now the value of this 1 by 4 pi epsilon 0 is, the value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. Okay, 9 into 10 raised to 9 Newton meter square per Coulomb square. Okay, Coulomb square. Clear? Okay, therefore what is F? F equal to what? The value of this term is 9 into 10 raised to 9 into Q1 Q2 by R square. Okay, Q1 Q2 by R square. Clear? Okay, then if the value of Q1 and Q2 are 1 and the separation or the distance between these two stationary charges is 1 meter, that is Q1 equal to Q2 equal to 1 coulomb and R equal to 1 meter, then what is the force or the amount of force? F equal to, here Q1 equal to 1, Q2 equal to 1, R equal to 1. Therefore, this term is go to 1. 1 into this term, that is F equal to 9 into 10 raised to 9 Newton. Okay, from which condition? Q1, Q2 equal to 1 coulomb and R equal to 1 meter. So, we can define the unit of charge coulomb as follows. That is, 1 coulomb is that charge which when placed in free space at a distance of 1 meter from an equal and similar charge repels. Okay, equal and similar charge repels with a force 9 into 10 raised to 9 Newton. Okay, that is 1 coulomb is that charge which when placed in a free space at a distance of 1 meter, with the same charge. Okay, that time what happened? The charges are repelled with a force 9 into 10 raised to 9 Newton. Okay, that is, this is our Coulomb's law or inverse square law. Okay, I hope you all are understand today this session, that is Coulomb's law and inverse square law and properties of charges. Okay, thank you.